In this lecture, we're going to explore what happens when new fails. In the last lecture, we saw that we could use the new operator to allocate for new memory on the heap and use that to do stuff. And in most cases, the new operator is going to succeed. But in some rare cases, it is going to fail. And when you don't do anything about that failure, your program is just going to crash, and you might want to do something about that. I have to say that it is very rare for new to fail in practice. So you're going to see a lot of code out there that just uses the new operator. It doesn't really care about checking if the operation actually failed or succeeded. So this is a very rare case, but if you need to handle it, we're going to see how you can do that in this lecture. Here is a simple example that is going to try and force the new operator to fail. In the first statement here, we are using the new operator, but we are using a syntax that is going to try and allocate a lot of integers in one go. You see that it is an array, but we haven't really seen how we can use an array like this. So just think of this code as a piece of code that is going to allocate a lot of integers in one go. And we're going to try and make this fail. I have to say that this may give you an error on some compilers saying that you are exceeding the array size. If that's the case, no problem. We're going to find another way to get this new operator to fail. We are going to put a thing like this in a loop, and we're going to loop a lot of times, enough to exhaust the heap that is allocated to our program here. And when that happens, you're going to see that the program is going to crash, and it is bad. So new can fail, and if you need to play on the safe side, you're going to handle that problem. And we have two ways we can handle this problem. We can go through the exception mechanism. This is a built-in way we have in C++ to check for errors and handle them. We can also use the std no throw setting in our new operator and force it not to throw an exception, and it's going to give us null pointer if the allocation fails. I know this might sound cryptic right now, but we're going to see an example shortly and you're going to understand this. Let's look at how we can use the exception mechanism. The exception mechanism is there in C++ to let you handle problems when they arise. And the way you use that, you wrap code that is potentially going to give you problems in try and catch blocks. You see here inside the loop, we are saying try. And inside the try blocks, we have the code that could fail. We have our new operator. And in the catch block, you see we have a catch block here. We're going to say that we have a problem and we have a way of catching the problem. And if you look at this thing we have in this parenthesis, after catch, we have an EX variable and we can ask it what kind of problem happened leading to this exception happening in our code. You can think of this like this. I realize we haven't really talked about exceptions. We are going to talk about them later in the course when we have enough tools to really understand what is happening. But now, think of them as a tool to handle when the new operator fails, and you're not going to crash your program. Your program will keep running. It will go through the end, but the new operation that you wanted to do here will fail, and you will be able to catch that. And this is a good thing. If you don't want to use exceptions, you can use the std no throw option. And this is a new version of the new operator you can use to tell the C++ system to not throw an exception when the operation fails. It is just going to return null pointer, and you can check for that and know that memory allocation actually failed. This is what we're going to talk about in this lecture. I hope you have an idea about this. We're going to head over to Visual Studio Code and actually try this in action. Okay, here we are in our working directory. The current project is when new fails. We are going to grab our template files like we always do, and we're going to put them in place. So when new fails, that's the lecture. So we're going to do that and open this in Visual Studio Code pretty quick. And we are going to try and allocate a large piece of memory in one go. So the way you do that, we can do say int pointer. Let's call this data. It really doesn't matter. And we're going to say new int, and we're going to say that we want a huge amount of ints. Let's try and do that. And we're going to go down and say program ending well to make sure we know when we are ending this program properly. So let's try and compile this. We're going to bring up a terminal, and we are going to build with GCC as we always do, and the build is going to be good. Let's try and increase this number and push it to a really big number, and you see that we have made Visual Studio Code mad here. Array is too large, so they can't really allow us to do a really large array in here. Okay, so let's bring this down a little bit. And if we're trying to compile, the build is going to be good. And if we run Rooster, you see that the program is going to not end well. Okay, so this is really a case where new fails. We can't really allocate this much on the heap storage that is allocated to this program here. Remember when we revisited the memory map idea, we saw that each program is going to have its own memory map. The memory map is going to have a lot of sections inside. We have the stack, we have the heap. Our heap is not infinite, so we can run out. And we just ran out with this allocation that we did here. And our program is going to terminate. Immediately you see that it is not ending well. If this is not working for whatever compiler you are using, we can go and do this through a loop. So what we can do, we can comment this out, and we can really loop many times, enough to exhaust the memory that is allocated for this process here, rooster.exe, in the memory map, in the heap section. That's what I mean. And if we do this, at some point, the program is going to fail. And we're going to get the same problem here. So let's build again. We're going to build with GCC, and we are going to clear and run Rooster, and we're going to see it's going to loop, and it's going to fail. We're going to see the failure in a minute, and we need to find a way to solve this problem. We have seen that we have two options. Let's comment this out and look at those solutions here. The first option is to go through the exception mechanism. We can also use the std no throw option. We're going to try the exception mechanism first, and what we do is wrap possibly offending code in try and catch blocks. And we're going to say try here and put a block, and we're going to say catch, and we're going to say std exception, and we're going to put an ampersand symbol here. Just use this like this, and we're going to get a chance to really explain these things when we have enough tools to understand this. For now, think of this as, if I have code that is potentially going to fail, like the new operator here, I am going to put that in the try block, and if something goes wrong, we're going to get the error in the catch block. This is the way we do these things here. So for example, I can take my loop here and copy it and put that down below here. Okay. And I know that this line of code could fail. Okay. So I am going to wrap that inside try and catch blocks. So I am going to grab that and put that in my loop. Let's do that. And align this a little bit. And we are going to take the potentially offensive code and put that in the try block. And when the operator here fails, something goes wrong, and we're going to catch the problem in the catch block. This is what we mean here. Again, we don't have enough tools to understand why we are doing this thing here. What is the meaning of this ampersand symbol? We're going to learn about that later in the course. But for now, we want to put together something good enough for this program not to crash like it was doing right here. Okay, we're going to catch the error and say something went wrong. And we're going to print out what actually went wrong. We're going to say ex, and we can call a function called what on this. And we can say std endl. Let's hide this pane here because we want to see clearly what is happening here. This is how you can prevent your program from crashing, and it is going to end well because now we have handled the problem and we haven't caused a crash like we were doing down here. Now we're going to try and build this code. Let's bring it up a little bit so that it is not messy here. And we're going to build with GCC. The build is going to be good. And we're going to clear and run Rooster, and it is going to do its thing. It's going to keep looping around. and it's going to say something went bad. It's going to hit a point where all these allocations are going to fail. And if we really wait for it, it is going to end. And we're going to see that it's going to end well. Let's try and hit Control C and terminate it because we don't want to wait for this amount of time. And let's bring that down to 100 and increase this number here. Let's see if that actually works. So we're going to build. For now, we just want to see that the program is not really crashing. So we're going to run Rooster, and you see that it's going to keep running, and at some point it's going to fail to allocate memory and it's going to say something went wrong. But if you keep going down, you're going to see that the program is ending well. So what is happening here is that the new operator actually failed, but we caught the problem and could handle it in here. So what is called handling the problem? You're going to handle it in whatever makes sense in your program. If we were, for example, trying to set up a color in some widget in your application, and the color fails, and you fail to set up the color, you may show your user interface in black and white and keep running your program instead of getting a crash. This is just a way to show you that you can handle stuff when new fails. This is one way we can solve the problem. So we're going to look at the second way. The exception mechanism is the first. So we're going to comment this out because we're going to see another way. And let's do that. We can also use the std no throw setting on our new operator when we are allocating for new memory. So we're going to do that. And we're going to bring up our loop here. We're going to reuse that for this. Here we're not going to be using the exception mechanism. So we're going to do something like this, get rid of the try and catch block, but we're going to still be in our loop here. So what we can do is pass the new operator a parameter and say std no throw. And when we do this, if new fails, we are going to get null pointer stored in data here. So we can check this against null pointer. We can say if data is different from null pointer, and we can do whatever we want to do. We can do that and say stdcout data allocated, and we can try and compile this program. So what we're going to do is run this through our compiler, through GCC, and you're going to see that the build is going to be good. And you see that Visual Studio Code was giving us a squiggly line because it can't really understand this, but this is going to go through the compiler and it is going to work exactly how we expect. So let's try and run this program. We're going to ignore Visual Studio Code for now because the build was good. We could build with GCC, and we saw that this was building successfully. So we can clear, let's clear properly and run Rooster. And it's going to say data allocated a few other times and the program is going to end. You see that the program is not crashing because we are also handling the problem, but we are going through a new mechanism to do that. And that's using the std no throw option with our new operator here. This is really all we set out to do in this lecture. I hope it is very clear that the new operator can fail, and you have a couple of options at your hands to handle things when new fails. You can either go through the exception mechanism by using try and catch blocks like we did here, or you can use the std no throw option. We are going to stop here in this lecture. In the next one, we're going to learn about null pointer safety. Go ahead and finish up here and meet me there.